prove that the triangles formed are congruent. Then we can say that RS is congruent to RT and prove that the big triangles are congruent. All right, so we're trying to prove that angle S is congruent to angle T, and all we're given is that PR is perpendicular to ST. PR is perpendicular to ST. So, all right, lovely. So the first thing, we're going to do an SR proof here.
Okay.
Statement and reason, is that kind of what you've been seeing in your book? Kind of looked like what they were doing.
Yep.
Yeah. There's also paragraph proofs and flow chart proofs. Boy, I hope this is not as long as we need it to be. Okay, so the first statement is almost always the given. Circle Q, and you can even add in the fact that PR is perpendicular to ST. Those are given. You always start out with your givens. So because PR is perpendicular to ST, you can say that, well, we have to be careful here. We can say that they're both 90-degree angles. Is that okay? Like and depending on your class, you first have to say that because they're perpendicular, it makes a 90-degree angle, and then because they're both 90-degree angles, they're congruent. I don't know how like specific your instructor is, but I think we can just go right to angle SRP is congruent to angle TRP. And the reason is that right angles are congruent. So the reasons are usually the hardest part for students, but it's sort of the thing that you're just saying out loud. All right, they're both right angles and they're both congruent.
Yeah.
Okay, now they don't give you very much here. So what you can do next is draw SQ like it says here, and QT, and those are also congruent. Is that okay? All right, so I'm going to just switch colors here. We can say that, let me pull it up on the other screen. Okay, QS is congruent to QT. All radii are congruent. All right. Now, what I like to do, and I think is really helpful for students, is to actually just separate like this little triangle from the big triangle. So if I do that here, and actually I don't have a good place to do that, so I'll just do this off to the side here. Here is what we have said thus far. We have said that these meet at a right angle, and that that these are congruent. So the next thing you can say is that SQT is an isosceles triangle, because that two congruent sides. Sorry. So that's the next thing here, is to say that triangle SQT is isosceles, and you have to say with vertex Q, and that's the converse of the definition of an isosceles triangle. So if it were isosceles, you could say that the sides are congruent. Since you're using the fact that the sides are congruent to say that it's isosceles, you use the word converse. That's a logic thing. So what that allows us to say is that this base angle here is congruent to this base angle, which is different than what we already said, but it's now RSQ is congruent to RTQ. So we now say the base angles are congruent. So angle RSQ congruent to angle RTQ. And the reason is So some students can just simplify this. It's same sides, same angles, but it's because the base angles in an isosceles triangle are congruent. Okay, so where does that leave us? Well, it leaves us with the fact that we're getting really close to proving that these two triangles are congruent. We can prove that triangle SRQ is congruent to TRQ. So these two triangles are congruent because we have an angle and another angle that are congruent. So there's this thing called the no choice theorem. I don't know if you've heard that before. That basically says the third angle must be congruent.
In Euclid's, we had a very simple saying that wouldn't require all these steps, which is just an isosceles triangle bisected will have equal angles. And so
Yes,
when
right.
that being said, we could basically just, get that proof, just say that, and then that'll be it.
Yes. So the proofs are, there's a lot of ways you can go. And I mean, I'm just picking away. I'm sort of like,
Yeah.
I'm sort of stepping through it, but there's what you need to do, what we're trying to prove is that angle S is congruent to angle T, which
Mhm.
requires us to prove that the two big triangles are congruent. So to do that, we need to prove that the two sides are congruent, which we're about to do. And we're about to show that it's a right angle. And so there's
Mhm.
and then we're going to show that this side is reflexive. So we're going to have a side, an angle, and a side, and we're going to have it. That's where we're going. But I mean, there's so many ways to get there. So like right now, we can now prove that SRQ is congruent to TRQ. We really do need to say though that these other angles are congruent
Mhm.
by the no choice. Then we can say that they're congruent because right now you only have angle side side. There's no angle side side theorem, but there is an angle side angle theorem. So we got to say that by the no choice theorem or any variation on that. And it's that the angle RQT is congruent to RQS.
Okay.
And then you can say that the triangles are now congruent. You can say that triangle, you got to do the order's got to be right here. RSQ is congruent to triangle RTQ by angled side angle theorem. And then we can say by corresponding parts of congruent triangles are congruent, that SR is congruent to TR. And that's the biggie. We really need that because what we're trying to show here is that in this big one, which we know they meet at 90-degree angles, this is the same as this. We know that the two angles are already congruent, and we can say that this other side is congruent to itself by the reflexive property. So 9 is that RP is congruent to RP or PR. And then that's reflexive property. And then we can say that the triangles are congruent by triangle, I'll relabel this S and T. So RST, the upper one is congruent to the bottom one, RTP, order matters. And that is by side, angle, side, SAS. And then you can say that angle S is congruent to angle P by ZP, CTC.
Mhm.
Now I'm happy to do as many proofs as you want in this hour. They are slow, so just keep that in
Yeah.
mind. But we can go to number 4, 5, and then go back to the previous ones if you would like.
So I'm just looking at 7 today. We are, okay, so obviously the lesson is short, but we're supposed to skip question 1, 2, 4, and 5.
Oh no,
So,
we just did one.
well, that doesn't matter. There's also learning value in that. But
There is, but
yeah.
so we got to do
Let's-
2 or no, 3. You said we need to do
yeah,
3.
yeah, we can do 3.
Okay. All right. Well, sorry about that.
Mhm.
All right. Where's the, oh, there's the proof. Okay, so we need to prove that CE is congruent to AE. So that's looking a lot like a triangles are congruent proof. So we're given that BE bisects angle ABC. So we can show that that means that these are going to be congruent. Oops, that's wrong.
Mhm.
After we write the given. So like that's like the what is it? The thing that comes after, like one leads to the other. So it's given this and it follows that this is true, and then it bisects the other one, CEA. So these are going to be congruent as well. This is a much more simplistic proof. So we can start with BE bisects angles ABC, and that's given.
Mhm.
Now, the other approach to writing proofs is that you don't put all the givens, you just use them as you need. So in this problem, we're going to use that given and then say that angle ABE is congruent to angle DBE. A lot of times, like students are like, well, what do I write as my reason? What is the reason? And the reason is whatever this is, it's definition of an angle bisector.
Okay.
It bisects this segment bisects the angle. So as a result, your reason is the definition of an angle bisector.
Mhm.
All right. Now we can get the second given. So the givens don't have to come in order that they appear. Bisects angle CEA. That's also given. So we can
Mhm.
now say that the two angles on the right are congruent. So we can say that angle AEB is congruent to angle CEB. And again, that's definition of an angle bisector. There's a lot of practical examples. You could make it as simple as like, um, you know, the door, people go through the door, definition
Okay.
of an open door. I mean, there's so many things like, but that's all it is. You just say that the thing that it follows from the thing that it's saying. All right. So in terms of how you prove triangles congruent, there are, if it's not a right triangle, you have side, 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 angle, side, angle, and angle, side. You have two angles congruent. So you are likely using either angle, side, angle, or angle, side. Do you see another side congruent in this picture? Not the one we're
Okay.
trying to prove, but do you see one that's congruent?
Um. Hmm. A and C.
A and C, there is no line connecting them, which means you would have to
Hmm.
draw a line. So
Okay.
sometimes you have to draw the triangle separate, and then it becomes clear what's congruent. So let me do that for you here.
Okay.
So A, B, E, and then you draw them separate here. B, E, C. Do you see any segments that are congruent now?
BE and
Yes, it's congruent to itself.
yeah, I was like,
It's
oh, okay.
sometimes you gotta break it apart to see that.
Yeah, you gotta see the bigger picture.
Yeah. And that's reflexive. It's like when you look at the mirror, you see yourself, hopefully. It looks the same. All right, so that's good because now we have an angle, a side, and an angle, a side, and an angle. So the triangles are congruent by ASA. For right triangles, you can use the hypotenuse leg, but this is not a right triangle. Right, so here's what we got. We got triangle. The order matters here. So ABE congruent to CBE. And the reason is angle, side, angle. And then you can prove that CE is congruent to AE by CP, yeah. So the CE is congruent to AE, CP. Whenever you use triangle congruence, you almost always use CP. Any questions on that or thoughts?
Negative.
All right. Okay, so instructions. Oh my gosh. Okay, do we need to do some constructions here, like 123?
You mean, yeah,
Like, do you want me to show you how to do them?
yeah, sure. Is that the compass, for example?
Well, I'll do my best.
Gotcha. Oh yeah, yeah. I just mean like when
Do
and
you have a compass and a protractor?
well, we're supposed to do it with them. We ain't allowed to do them without, so
Okay. I'm not I'm not the judge. You're the judge. You're just asking if you got
yeah.
one.
Hey,
Right.
I'm fine with just being rough, My teacher is not
Yeah.
though, but
Yes. All right.
a
So
good point.
the let's just draw one of these. So
Okay.
let's draw a 4. Roughly that's 4. Roughly that's 3, and roughly that's 2. Okay, do you agree with that?
Yep.
I mean, roughly. All right. Now I have the advantage here of drawing some circles. Let's see if I can do that. So that's the first one. Probably see where I'm going with this. I don't know, it's not that good, but let's go another one here. Oops. And so we can make this one a little bigger to represent the other one, the radius of the other one. I don't know. Kind of get kind of close. So you have to draw 3 circles, and then you can if you do a nice job, they intersect. We'll see here in a moment if we get this right. Oh, well, that's not very good. Yeah, there's kind of rough. Okay. How do I want to? So you start by. How do we want to do this? So I want to give you the order here. So you just pick a vertex and you say, okay, that's 4. So you swing a circle. And you go to that point and you swing a 2. So you swing a like that. And then you go to that point and you swing a 3 like that to get it.
Okay.
That should be acceptable, roughly.
Mhm.
This is even more useless than the proofs, but it used to not be. It used to be that with architectural drawings and before computers and people that program computer software, they did have to know this stuff, but um,
Mhm.
you don't really. I mean, you don't really need to do that. Okay. Use a ruler to draw a line segment that is 4 centimeters long. So here you assume that that's 4 centimeters long, not to scale. Construct a perpendicular to the segment at a point on the segment that is 1 centimeter from the left endpoint. Okay. So you could swing an arc that's like got a radius of 1. You could kind of do that to figure out where it is. That's that. But then to draw the perpendicular, you would stick the sharp end of the um, compass in here, and then you would swing an arc, and then you would use these 2 points here to stick the pointy end in, and you would swing an arc down here and an arc down here, and you go up to the top and swing an arc and an arc, and there would be a line that goes right through them that perfectly bisects. I'm sorry, perpendicular to that.
Mhm.
What do you think? Is this is it reasonable? Do you remember doing this in your other
Mhm.
class?
Mhm. Yes, sir.
All right, good. Okay.
Versus graphing paper makes it easier, kind of cheap, but whatever.
Yeah, I mean, you can do anything you think will pass the eyeball test here for your instructor.
Yeah, exactly.
All right, so here we go. Draw a line and a point not on that line. Construct a perpendicular to that line that passes through the point. Okay, so probably sounds harder than it really is. Boy, that is not straight. So let's just say here's your line and here's your point. Okay. Construct a perpendicular to that line that passes through the point. So you go to that point and then you swing an arc,
Mhm.
and then you have a point and a point. Then you go uh, back to each of those points and you swing an arc, so that you get that intersection, and then you do the same thing down here from the 2 points that you've created, and then you draw a line with the ruler right through it.
All right.
Is that okay?
Yeah, yeah. Sorry, I wasn't sure if you wanted me to like.
I don't. It just. I mean, unless you're gonna do it. I mean, there's no.
Oh, good.
You just copy the
Yeah,
strokes here.
yeah, that looks right. Afterwards, I
Paint by. Good.
afterwards I'll you know copy it and go over it, and then I put that in my notes. So
Cool.
yep.
Okay. Use a protractor to draw a 36-degree angle. So let's just say for a moment that that is actually 36 degrees.
Looks about right.
All right. It's it's so the next thing here is to bisect it. So the first thing you do is you go there and you swing this huge arc somewhere there. Then you go to each of these places and you swing an arc like that. Go here and swing the same arc like that. And these points end up creating the midpoint between there.
All right, very well. So that's going to be 18 degrees, obviously.
Yeah, yeah. And so you should measure. I mean, if I were grading it, I would measure and say, okay, it's, if he's kind of around that with all the right marks, I'll give him
Mhm.
the points. But these are a huge pain to grade, and especially if you're going through, scanning your assignments, they're just not great. Okay, that
Yeah.
is it for constructions, it looks like. Um,
Mhm.
Looks like you got some probability stuff maybe here that we haven't done much of. I don't know. 15 is also kind of 14 and 15 from last time. What else? So it's just the 20 today?
Yeah.
Okay. Anything kind of you're seeing that you're struggling with here or not sure about? What would be best for
Uh,
you?
I mean, whatever you think would be
All right.
most
So
helpful.
let's do 15.
All right.
15. All right, x is an element of the real numbers. That's nice. X squared minus 6x is greater than minus 9. We're going to add 9 to both sides. X squared minus 6x plus 9 is greater than 0. This is a perfect square trinomial. We know that because you could take the square root of the first, the square root of the last. When you double it, you get 6. That means it's x minus 3 squared, like this. Now, graphically, what this looks like is at 3, it comes down and bounces off.
Yeah. But when it comes to the number line, that's
So the only place it's 0 is at 3. Everywhere else it is greater than 0. So like you said, you go to a number line and you say, okay, that's 3, but everywhere else it's positive.
yeah. Okay. Very well.
So it's everything. We would express this as minus infinity to 3, union 3 to infinity.
Mm-hmm. Sounds good.
Does that work?
Yes.
Okay, now the other one next to it, the 114, is being solved over the set of integers. It's an important distinction, I suppose. So typically for these problems right here, these are the between because it's less than. So you're at x minus 5 less than 3, and
Mm-hmm.
then negative 3 on the left there. So
Okay. So the 2 smaller than x, smaller than 8. It's gotta be, I think, in between there.
you add 5 like you're saying.
Mm-hmm.
2 less than x less than 8. And you want all the integers though between there. So
Mm-hmm.
your answer is a set 3, 4, 5, 6, and 7. It's not everything.
Yeah,
Um,
yeah. Right. So yeah, it's just gonna be the integers. Gotcha.
um,
Well, so here the wind blowing outside.
I cannot hear it. It is
Okay.
windy today.
Yeah. I'm in the garage, so it's very loud, but that's all right.
All right, so let's look at number 16. I want you to try setting up the equations. That's really the hardest part here. So um,
Mm-hmm.
I'll let you give that a try. Just don't solve it. Just set up the equations,
All right.
and then we'll look at it together.
Very well. pencil. All right, there we go. Okay. Um, um, Okay, so in our book, we use subscripts. I know you don't like them. I don't really like them either, but
Could use X1 for Melvina, or Beulah.
I mean, I just used these subscripts to indicate their age at the time because that's how they do it in our book, which is frankly rather confusing. But so I got M subscript to 20 equals 4 plus 2B subscript to 20. So basically, when they're 20 years old, M equals 4 plus 2B. For the names, obviously. And the B and M in this next one, subscript to 6, B equals 3/5 M. And so that's in our book how they're set up, basically.
Let me add. So 20 years ago, so M minus 20. That's because the variables are M and B for their current age, or if you want to use subscripts, you can. 4 years older than twice Beulah's age. So Beulah was also 20 years younger, and twice plus 4. So do you have something like this with your subscripts or not?
I usually use subscripts, but
Okay. Well, here, why don't you go ahead and solve it then, and then we'll just compare answers.
okay, very well. Okay. Oh wait. Hold on. Okay. I got B equals 20 and then M equals 24.
Okay. I am just a tiny bit behind you here.
Okay.
X minus. Huh.
I may have got it wrong.
Beulah was 3/5 as old. I'm sorry, I'm running into a little problem here.
No worries.
20 years ago was 4 years older than twice Beulah's age then. 6 years ago, Beulah was 3/5 as old as Malvina was then. I feel like I typed this wrong. I did get a reasonable answer, but I don't like it. Plus 4. So you said you got Malvina is 20 or 24?
Uh, Melvina
Now.
was 24 now, and then Beulah was 20. At least that's what I got.
Okay. 6 years ago, 18 and 14. So that's not quite right
Mhm.
because the numbers don't, I mean, it's close. So there's something not right. 20 years ago, Melvina, 20 years ago, minus 20, 4 years older than twice Beulah's age, then B minus 26 years ago, M minus 6, B minus 6. Beulah was 3/5 as old as Melvina. So that looked to be in the wrong place.
Mhm.
Okay, that's the issue with what I've got there. Yeah, okay. So these are way off here. So Melvina is 56 and Beulah is 36.
Okay. Hmm. Okay.
And so 20 years ago, so now that's their current age. So 20 years ago, 36 and 16. If you double 16 and add 4, you get to that. That's good.
Mhm.
And then 6 years ago, it's 50 and 30, which is 3/5 of
All
that.
right.
So I would recommend not using the subscripts. It's great for other
Yeah.
classes, but I'm not, I mean, if your way's working,
Yeah.
please, it's up to you, but that's just my opinion.
All right. Well.
Okay. So we haven't done, well, let's do 20. We haven't done 20 in a while.
Okay.
This is one of those repeating ones.
Hmm. Okay. So n equals 0.03, 154. 100 n equals 3.154. And then add that together, 99 n equals 3.13 or something like that.
Yeah, so it's 154 over 999. That gets you this part, but then it's really you've got this other thing going on, right? You've got this 0.03.
Mhm.
So it's 3 times this, a lot of ways to do this, times 10 to the minus 2. So that's the 3 over 100.
Okay.
Does that look familiar?
Um,
You can, and you can always go to the calculator. You can always just say, okay, 3 over 100, that gets to 0.03. Then
mhm. Yeah.
times 154 over 999. That does not get me what I want. I'm sorry, that's not right. 0.03.
Yep.
So it's plus. I'm sorry, it's plus. That's what the issue is. No, that plus that. This one is more, I apologize. This one is more difficult. Yeah. So I apologize. This is completely wrong. I mean, it's not completely wrong, but you have to look at this as 0.03 plus 0.00154 repeating. So this 0.03 is 3 over 100. This right here is 0.154 times 10 to the minus 2. So that becomes 154 over 999 times 1 over 100.
Yep.
And so your instructor probably wants a common denominator. So the common denominator you get by multiplying the left top and bottom by 999.
Oh, that's right. That's the simplest thing.
So it's pretty bad here. I mean, it's not, it gets, worse before it gets better.
Mm-hmm.
And so you got to do that 3 times 999, which is 2997 plus 154.
All right.
That's 3151 over 99900. And you can always check this, like as you're doing it, you can check every step and make sure it still equals the fraction that you're looking for. And then this one, does it reduce? It does not.
Mm-hmm.
But that'll do it.
All right.
So we've done quite a few variations on that, but hopefully becoming clearer and clearer.
Mm-hmm.
All right, number 16. No, sorry, 17. We haven't done kind of one of these problems. This is 17. You'll often see in a class where they try to explain why you shouldn't guess on a problem here. So true false quiz is 12 questions. How many permutations of the answers are possible? So there's a couple of ways to do it. I like to draw these buckets to kind of show, let's just say it was a 4-question quiz. There's 2 options for each one. So it
Mm-hmm.
would be 2 to the 4th, which is 16. In yours, it's 12, 2 to the 12, which is a lot. I mean, it's not as many, but it's a lot. So 2 to the 12, you might remember 2 to the 10 is 1024, and then you're doubling that again. So 2048, 4096. So just guessing, you would have a lot of possibilities. You don't want to guess.
Mm-hmm.
And it gets worse. It gets worse for a multiple choice. It's like if you have 4 answers in multiple choice, I mean, these numbers just go up a long ways. Now,
Yeah.
18's related. It's related here. This is the kind of like how to arrange books or letters. So you got 4 letters, A, B, C, and D. And you got to pick a letter to go in the first position. How many letters are there that you can choose to go in the first position?
Mm-hmm.
You got 4 possibilities, but then you've taken one away. You don't know which one you've taken away, but there's one you've taken away. So now there's 3 left over.
2.
Then there's 2 left over. Then there's 1. This is factorial, 4 factorial, 4 times 3
Mm-hmm.
times 2 times 1. It grows also very, very quickly. So if you ever wonder, well, how many ways can I arrange books on the shelf or sit 4 people around a table? There's a lot of ways.
Yeah.
All right.
All right.
Why don't you try 12 and 13 here, and I'll check your answers. These are calculator problems
Right.
anyway, so
Very well. All right. I got negative 3.39.
okay, I agree for the first one. Second one's
Okay,
got a little
yeah.
more work to it, but you can do it.
Mm-hmm.
The undo ln.
I get 0.54.
You got something different here. So this is the 0 here. You're
Mhm.
dividing by 3. So it's natural log of x equals minus 5.13 divided by 3. And then you undo ln with e. So make sure all of that's in the exponent.
Oh, okay. Let's see.
Get a result for that.
Let's see. So remind me about E again.
Literally an e in Desmos, just the
Oh,
transcendental
right.
function, but it's just e.
Huh,
It's just e.
forgetting about that. Okay. Right.
All right. So you
I was
should get
thinking it can't be
point.
that obvious. 0.18.
Yeah.
Yeah,
All right. So last
0.18.
problem.
9.
Last problem here. So this is a PERT problem, PE to the RT. So Stephen deposited $1,150 at 8% compounded continuously, which never happens in real life, but that is a math problem. It's like the 5,000 bananas you buy at the grocery store. How much did he have at the end of 11 years? That's T. So this is the future amount that he's going to have.
Okay.
You've probably seen that equation, that PERT, before,
Yeah.
and it's actually quite significant. The best you can really get is daily, which you don't really know anybody doing that. Most things are compounded monthly.
Mhm.
All right, so we're gonna stop there for today.
All right.